In the realm of science and cosmic mysteries, the question of what existed before the Big Bang has stirred debates and captivated people's minds for centuries. This profound question doesn't just challenge our understanding of the universe, it challenges human boundaries entirely. Imagine standing at the edge of existence, staring into the vast darkness, and wondering what lay there before our universe was born. The moment of the Big Bang marked the beginning of time, space, and everything we know. But was there a moment before this? Could there have been periods of inactivity, a silence before the cosmic orchestra started? And if so, what was it? Or maybe there was something far more terrifying that existed before time itself. As we dive deeper into this question, science takes us on a journey beyond the universe's origin, into concepts that defy our understanding. Physicist Brian Cox, known for his exploration of the wonders of the universe, suggests that something terrifying might have existed before the Big Bang. He challenges us to reconsider our notions of reality, time, and space. In this exploration, we'll examine the science, the theories, and the jaw-dropping mysteries that might explain what existed before everything. We'll look into ideas like cosmic inflation, dark fluctuations in quantum physics, energy, and even multiverses. The answers we've uncovered might just shock you, but they could also unlock new understandings of our place in the cosmos. Get ready to dive deep into a world beyond imagination and science, where the unknown still looms in the shadows, leaving scientists astounded and sometimes even unsettled. Let's explore what existed before the Big Bang and why these theories cast doubt on everything we thought we knew. Understanding the Big Bang. To understand what might have existed before the Big Bang, we first need to carefully examine what the Big Bang was. In fact, the Big Bang, as scientists define it, refers to the moment when the universe became incredibly hot and dense, rapidly expanding to create all matter, energy, and cosmic forces. When we look up at the night sky, we see evidence of this hot beginning, with galaxies spreading out in all directions from a central point. But why did this happen? And was there a time prior to this densely hot source? The theory of cosmic inflation. According to the cosmic inflation theory, there was indeed a before, and it was far from empty or peaceful. Cosmic inflation implies that, prior to the Big Bang, the universe was in a cold, empty, and stretched-out state, almost like a vast vacuum. However, this vacuum wasn't completely empty. It contained an immense amount of energy that powered the rapid expansion of physical space itself. This process, called inflation, happened so quickly that it essentially laid the groundwork for everything that would follow. Space stretched for a fraction of a second at a speed beyond comprehension until inflation slowed and the energy transformed into matter-like particles, leading to the force we call the Big Bang. But what was the nature of this energy? Why did it suddenly inflate the universe? And why did it stop? Scientists believe that cosmic inflation created patches of the universe, each experiencing its own Big Bang. Imagine a fabric stretching endlessly, with tiny bubbles forming here and there. Each bubble represents a universe, including ours. This concept, called the inflationary multiverse, suggests that there are potentially infinite Big Bangs and an endless number of universes. Ours is just one of many. This vast, mind-bending reality challenges our understanding of the universe itself and leaves us with a haunting question. What else is out there? Was there ever nothing? The concept of nothingness before the Big Bang is theoretical, not real, at least according to our current understanding. Even if you removed all energy, particles, and radiation from the universe, it would not be truly empty. Our universe is filled with dark matter, dark energy, quantum fields, and other forces that create an inescapable tapestry of something, even in its most vacant form. Even if we imagine stripping away all these forces, leaving a dark void, the universe would still create new forms of energy. This fact alone baffles scientists, as it suggests that true absence might be impossible within our cosmic understanding. As we probe deeper, we find that space itself has properties, rules, and constants that do not allow it to be completely void. Imagine creating a region with absolutely nothing in it. No particles, no radiation, no energy. But quantum fields and fundamental constants would still exist, meaning that this nothingness still has properties. For instance, there's a phenomenon called zero-point energy, which represents the lowest possible energy state of quantum fields. Particles can still briefly appear and vanish, creating a ghostly echo of activity, even in what ought to be empty space. This challenges our concept of a true void and suggests that, even before the Big Bang, something existed, something that scientists are just beginning to understand. The theory of eternal inflation. One of the most fascinating theories in modern cosmology is the idea of eternal inflation. If inflation caused our universe to exist, it's possible that it could continue indefinitely. Brian Cox describes a terrifyingly vast multiverse where inflation creates universes continuously, expanding without end. Imagine each Big Bang as a spark igniting a new universe, while inflation persists in other areas, creating countless other universes. This process could, in theory, go on forever. The idea of infinite universes gives birth to a fascinating concept of a fractal universe, where every new universe has the potential to create its own Big Bang. Each universe exists as a separate, self-contained realm, unaffected by the others due to the rapid expansion of space. For scientists, this theory is both exciting and unsettling, as it suggests a multiverse without an ultimate beginning or end. What if our universe is only one speck in a vast, ever-expanding cosmic structure? And what if the terrifying truth is that there is no before or after, but simply a never-ending series of universes forming and deteriorating? Quantum fields and the fabric of reality. Our comprehension of nothingness changes when we consider quantum field theory. According to this theory, the universe is more than just a collection of matter floating in space. Instead, it's a vast network of energy fields that interact with everything, creating everything we observe. These fields are like invisible oceans, with particles acting as ripples, waves, or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they are still active. Particles can form and vanish in these fields, using energy temporarily until it is returned. This phenomenon gives rise to virtual particles, entities that briefly exist and then vanish, leaving behind a faint memory of their presence. Virtual particles challenge the notion of emptiness. Imagine an empty universe as a true void where all matter, radiation, and energy are removed. Do you have complete nothingness? According to quantum field theory, you wouldn't. Even in a void, fields would occasionally remain active, producing brief particles. This constant activity in the absence of matter suggests that the universe doesn't align with our concept of nothingness. The fields and forces remain, filling the universe with an underlying energy that prevents absolute emptiness. This insight raises an intriguing question. If fields create particles and particles create matter, could the universe have emerged from this nothingness filled with quantum fields? Dark energy, a mysterious force that currently drives the accelerated expansion of our universe, may have existed before the Big Bang. According to scientists, the dark energy we observe today is a relic of an energy field from before the formation of the universe. Dark energy's properties suggest a vast hidden power that could have existed in some form before the Big Bang. Some theories propose that dark energy, in a much stronger state, could have powered the phase of inflation that allowed for rapid expansion. The presence of dark energy implies that, even if our universe were emptied of all matter and radiation, this force would continue stretching the fabric of spacetime. This idea leads to an alarming possibility. If dark energy was present before the Big Bang, it might have shaped the circumstances that resulted in the birth of our universe. Could dark energy be the silent architect of cosmic inflation, or even the true origin of our universe? As we explore this possibility, we confront the potential of dark energy not only as a force shaping our universe but also as a key to unlocking the secrets of the multiverse itself. Another theory that offers an alternative to the Big Bang as the ultimate beginning is cyclic cosmology. The idea that the universe goes through endless cycles of birth, death, and rebirth. In this model, the Big Bang was not a one-time event but rather a component of a cosmic rhythm in which universes expand, collapse, and then re-expand in a new cycle. This theory argues that the universe could have been reborn from the remnants of a previous universe. The process of contraction and expansion in a cyclic pattern would mean that there was never a true beginning but instead an infinite sequence of emerging and evolving universes, renewing themselves over and over. Cyclic cosmology raises significant questions about time. It suggests that time itself might be circular rather than linear. If this theory is true, it could mean that what existed before the Big Bang was simply another version of the universe, one that collapsed only to give birth to our current universe. For scientists, this theory offers an elegant solution to the question of ultimate origins by suggesting that there isn't one. Instead, the cosmos has always existed in one form or another, transcending our notions of time and existence. Primordial gravitational waves are another fascinating concept that might hold clues to what existed before the Big Bang. Gravitational waves are ripples in spacetime caused by massive cosmic events, and scientists believe that, if found, primordial waves could reveal details of the universe's earliest moments. These waves would be remnants from the inflationary period, carrying information about what happened during the first fraction of a second after the Big Bang. But what if there were waves that predate even the Big Bang? Some theories propose that gravitational waves from a pre-Big Bang era could exist. If such an era existed, identifying these waves could provide direct evidence of events or conditions before inflation and the hot Big Bang. However, discovering primordial waves from before the Big Bang is an enormous challenge. Scientists are constructing sensitive tools to detect these minute ripples, hoping they will reveal a buried layer of cosmic history. Such a discovery would not only provide answers about our universe's infancy, but also about the deeper forces of the cosmos that may have sparked its existence. Quantum foam, a concept proposed by physicist John Wheeler, is another theory that hints at the possibility of a pre-Big Bang reality. In quantum mechanics, space is not truly empty but filled with constant fluctuations of energy on the tiniest scales. Quantum foam suggests that, at the smallest time and space scales, particles can form and vanish in fleeting moments, giving rise to. This idea is like temporary energy bubbles. It supports the vacuum genesis hypothesis, which posits that the universe could have come out of a massive quantum fluctuation in the quantum foam-filled sea. The vacuum genesis hypothesis proposes that what we perceive as the Big Bang might actually have been one of these increasing energy fluctuations until it became the universe. This view redefines the idea of nothingness, suggesting that even in the absence of matter, energy, and traditional spacetime, there still exists a dynamic reality. If our universe is indeed the result of a fluctuation in quantum foam, then there might be other universes appearing and disappearing within this quantum sea. This notion expands the multiverse theory and suggests that our universe's existence may be significantly more common in the grand scheme of cosmic phenomena. Quantum tunneling is a phenomenon in quantum mechanics where particles can pass through energy barriers even when they don't seemingly have enough energy to do so. Therefore, the idea of tunneling is fascinating when compared to the entire universe itself. Some cosmologists propose that our universe could have tunneled into existence from another dimension or reality. Quantum tunneling would allow energy to break through an otherwise insurmountable boundary, resulting in a universe arising from a different plane of existence. This theory adds a baffling layer to the idea of what existed before the Big Bang, as it implies that our universe could have leaked or tunneled into being from another world. If this theory is true, then our universe could be just one of many that form, evolve, and vanish within a much larger hidden structure. Quantum tunneling provides evidence that the Big Bang might not be the beginning but rather the result of a boundary being crossed, a moment when our universe emerged into the vast unknown. As we explore these theories, it becomes clear that our comprehension of the origins of the universe is limited but evolving. The Big Bang was once thought to be the end-all be-all, the singular point from which all existence sprang. But now, with concepts like inflation, the multiverse, and quantum fields, we see a much more intricate tapestry. Scientists like Brian Cox push us to imagine that something existed prior to our universe, something powerful enough to ignite the Big Bang and set off the chain of events leading to our existence. The consequences of these theories are both exciting and humbling, reminding us that the universe is full of mysteries yet to be solved. So, what existed before the Big Bang? While science may one day reveal more answers, for now we stand at the edge of what we know, peering into the unknown with curiosity, awe, and a bit of fear. The vastness of the cosmos, its intricate designs, and the mysteries it holds remind us that our place in the universe is both remarkable and fleeting. Embracing this mystery is part of what makes us human and inspires us to continue exploring. As we continue to explore the mysteries of what may have existed before the Big Bang, it's essential to consider the influence of theoretical physics on our understanding. While the concepts of quantum mechanics, inflation, and the multiverse provide compelling theories, they all point toward a fundamental idea: the universe is far more complex than we first envisioned. The very nature of time, space, and reality itself seems to be much more fluid than our everyday experiences would suggest. One fascinating concept in this area is the nature of time as we know it, which may not have existed prior to the Big Bang. Some interpretations of physics, particularly those relating to quantum gravity and string theory, suggest that time is an emergent property of the universe rather than a fundamental, intrinsic aspect of reality. If this is true, then time itself may have come into being only when the conditions for matter and space were brought into motion during the Big Bang. Before this moment, there may not have been a before at all, no chronology or sequence, only a timeless state that defies human comprehension. Moreover, some cosmologists speculate that the very laws of physics, as we know them, might not have functioned in the same way before the Big Bang. In this pre-universe state, the principles of causality, which govern how events unfold, might not have been in effect. This leads to the mind-bending possibility that the common principles of cause and effect that guide our perception of reality could be completely distinct, or even irrelevant, in this primordial state. In this view, the Big Bang may not be a single, unique event but rather part of an ongoing cyclical process of cosmic evolution. This aligns with the idea of a big bounce, where the universe contracts to a singularity before expanding once more. Such a theory offers a potential solution to the question of ultimate origins, suggesting that the universe's birth may have been preceded by a prior cosmic contraction, leading to a never-ending cycle of birth, death, and rebirth. These ideas highlight the human capacity for knowledge but also underscore how close we may be to uncovering a new chapter in our understanding of the cosmos. Each new discovery, whether via the identification of primordial gravitational waves, further study of quantum fields, or advancements in string theory, could one day offer us deeper insights into the nature of existence itself. The journey toward these answers may not be immediate, but the pursuit remains one of the most exciting endeavors in science today.